Hello, thank you for checking out A1 Math, and today we're looking at steps for extending geometric sequence. What I'm going to show you how to do is how to extend a geometric sequence, add more terms to it, and also I'm going to show you how to use geometric sequence in a word problem. So let's begin. So here are the steps for extending a geometric sequence. When you have one, all you have to do is divide the second term by the first term to find the common ratio. Take the common, that should be ratio, and multiply it times the last term, and keep multiplying that common ratio to your last term to find your next term. So let me show you how that works. Okay, here we've got a problem, and it's already worked out, but some of the terminology used can be a little bit confusing. So I'm gonna try to keep it as simple as possible. Okay, so what you want to do is take the second term and divide it by the first. So the second term is 12. We're gonna divide it by the first term, 6. And when we do that, we get 2. So our common ratio, our R, is equal to 2. Now, we're just going to take that 2 and multiply it against the 48, and that'll get us the next term. So you'll have 48 times 2, and that gets you 96. So the next term is 96. Then you just take the 96, multiply it by 2, and that gets you 192. And you take the 192 and multiply it by 2, and that's going to get you 384. So your next three terms are here, 96, 192, and 384, and you can write them like that. All right, let's take a look at another example, okay? And I got a lot of boxes and all this over here, but I'm going to do the exact same thing we did over there on the first problem on A for B. You're going to take the second term, which is 50, and divide it by the first term, which is 100. So I'm going to take the 50 and divide it by 100. And that's going to give me a fraction. Don't worry about dividing the bigger by the small. Do the second by the first. So once you do that, you're going to end up with 0.5 or 1/2. So our common ratio is equal to 0.5. So now I'm going to take the last term here, which is 12.5, and just multiply it by 0.5. And when I do that, I get 6.25. Then I'm going to take the 6.25 and multiply it by 0.5. And that's going to get you 3.125. And then I'm going to take the 3.125 and multiply it by 0.5. And that's going to give me 1.5625. So the next three terms are 625, 3.125, and 1.565. Okay. Take a look at these two and see if you can find the common ratio and multiply it times the n. Don't let this fraction throw you off. You treat it just like any other number. Okay, so this should be what you get. If you had 0.33333 for your common ratio, that's correct, but it's a repeating decimal and it's hard to use. So it'd be better off to use, I should say negative, but you should use -1/3 on number 6. But let's talk about number 5. On number 5, you multiply your common ratio, which is 4 times your n term, 320, that last term, and you get 1280. Then you trade 1280 and multiply it by 4 to get 5,120, and then take 5,120 and multiply it times 4, and you get 20,480. So your next three terms are here. All right, over here, when you do negative 3 divided by 9, it simplifies to negative 1/3. And then the last term here, let me erase this, is negative 1/3. So you multiply negative 1/3 times positive, negative 1/3, you get positive 1 over 9. Then you take the positive 1 over 9 and multiply by negative 1/3, you get negative 1 over 27. Then take the negative 1 over 27 and multiply by negative 1 over 3, you get positive 1 over 81. So that's how you get these terms here. Okay, now what we want to do next is use a geometric sequence in a word problem. But before I do that, I want to go over the steps for writing a geometric sequence and finding the nth term. Similar to what we did in the previous lesson, you want to find the common ratio by dividing the second number by the first. You want to plug the first term of for ace of 1 and the common ratio r into the formula below. And then that's your geometric sequence. And then finally, you're going to plug in whatever term you're looking for, the nth term, and plug it in for n. Okay, so when we did this before, we just plugged in all the numbers at one time and take the part to the right of the equal sign and hit equal to find your answer. And we're going to use that again in solving these word problems. So let's take a look. Okay, here we've got a real world problem, and what we want to do is be able to recognizing growth patterns of a geometric sequence in context. So here we got somebody who's a bungee jumper. It says a bungee jumper jumps from a bridge. The table shows the bungee jumper's height above the ground at the top of each bounce. The height form a geometric sequence. What is the bungee jumper's height at the top of the fifth bounce? So it gives you a table here, and they won't always give you a table, but they say in the first bounce is 200, the next is 80, the next is 32. So we're going to do exactly what we did on the previous problems we did in the previous lesson. We're going to find these three things: the first term, the common ratio, and the nth term. So the first term is 200. So we'll use that 200 for the first term. And you can tell it's decreasing. Then we got to find the common ratio. The common ratio is going to be the second term divided by the first. So we're going to have 80 divided by 80 divided by 200. And when we do that, we end up with 0.4. So that's our common ratio. And then finally, we're going to find the nth term. Well, the nth term is the number of bounces we're looking for. So we're looking for the fifth bounce. So the nth term is 5. All right, so now we're going to come down here and we're going to plug those numbers in and then just type it in the calculator. So I've got ace of n. For n, I'm using 5. So I got ace of 5 is equal to ace of 1, which is 200, the first term. And we're going to multiply that times our common ratio, which is 0.4. I'm going to put it in parentheses. And all of that is raised up to the nth term, which is 5 minus 1 in parentheses. So the next thing I'm going to do is just type that straight to the calculator. And I'm going to say 200 times 0.4 caret, open parentheses, 5 minus 1, close parentheses, then hit equal. And once I do that, it'd be 5.12. So what does that mean? It means on the fifth bounce, if you look at the picture up here, it shows you the second bounce, the third bounce. On the fifth bounce, he'll be 5.12 feet above the ground. Okay, let's take a look at another example. Here it says a ball is dropped from a height of 144 inches. Its height on the first bounce is 72 inches. On the second and third bounce, the height of the ball is 36 inches and 18 inches respectively. The height from a geometric sequence. No, sorry, the height forms a geometric sequence. It says, what is the height of the ball of the sixth bounce to the nearest tenth of an inch? So we have our term, and if it helps to write that out, we go ahead and write out the sequence here. So the first one is 72, the second one is 36, and the third one is 18. So we're going to fill in everything we know. We know the first term is 72. We're going to find the common ratio by dividing 36 by 72, and that's going to get us 0.5. And then the nth term is the number we're looking here. It says, looking for. It says, what is the height of the ball on the sixth bounce to the nearest tenth of an inch? So we want to find it to the nearest tenth of an inch here. So we're going to have 36 divided by 72 to get the 0.5. And the tenth of the inch, or the nth term, is 6. So we're just going to plug these numbers in. We're going to plug in a to the sixth term, the first term, which is 36, times the common ratio, which is 0.5. And we're going to raise it to 6 minus 1. And then we're going to type this in the calculator just like it says. 36 times 0.5 caret raised to open parentheses 6 minus 1 close parentheses, then hit equal. Then once you do that, you'll end up with 2.25. And since we rounding it up to the tenth of an inch, we want to say it is about 2.3 inches. All right, go ahead and take a look at this problem, and it is on page 643, and see if you can solve this. Okay, this should be what you get for this one here. You should get 2.5 meters on the fourth bounce. Okay, all we did is took a list of terms here. We got 6, 4.5, 3.375. You divided the 4.5 by 6 to get the common ratio. Okay, you take that and you plug it into your formula and type that in your calculator, and this is what you get. And just round to the nearest tenth of a meter. Okay, and that is using a geometric sequence in a word problem. I want to thank you for checking out A1 Math. Have a nice day.